welcome everyone. I'm really excited about joining this session and hopefully you'll get to know Colin and myself a bit better throughout the session and the Q&A. The reason why we chose this topic, at least for me personally, I'm a big fan of retail. I used to work for a company called IRI before I joined TIBCO. So I've worked many years in the retail industry. We were looking at point of sale data and customer data at the time. And now with TIBCO, we're analyzing it with a lot of other context data as well. So the topic of today is visual data science in retail, and we'll explain throughout why we think that's really important. I have to share this confidentiality and disclaimer slide with you. Basically means that everything that we share with you today is for informational purposes only. And the agenda is, we'll start with an introduction of TIBCO, in case you don't know yet what TIBCO is or who TIBCO are. Then we'll give some real world examples of how data science and data and analytics are used in retail. And then Colin will go into the depth of how to build a recommender demo. And throughout this, we really want to talk about, why it's important to be really visual when you communicate about data science. Because you can use code, but it's much more effective if you make a very visual presentation, so you can involve more collaborators in in the impacts that your data science application can have. This is obviously an educational session. Everyone wants to learn, so we're sharing lots of links to resources so you can learn more. We've created a community page as well. Amy will share the link of that later in the session, so you can download all of these slides and access all the links that we're sharing. So who's TIBCO? We are a global software company, and we help our customers innovate with data, make better decisions with data. And we do that by providing capabilities in our software that allows customers to connect to all their systems, to unify their data, and to predict the future, which is obviously what we as data scientists do. And a lot of companies worldwide use TIBCO software. 21 of the top 25 global 2,000 companies, more than 10,000 companies and organizations overall worldwide, and across all of the different industries. And there are a lot of different capabilities available to our customers, and we refer to our overall capability as TIBCO Connected Intelligence. And when you think about customer data, it's really important that you can connect to all of the different systems or applications where your customer interacts with you. So some may do some research on the phone, some may buy on an online portal or go into your store. You need to be able to connect all of those systems. And you also need to understand and unify the data and make sure that you know that one customer is actually visiting you on these different portals and make that into one data point. It's also important that your data is governed. So for example, for customer data, GDPR is really important. So the Unify capabilities help you manage that. But today we're really going to talk about the predict aspects because of our audience of data scientists and data science leaders. And for us, that is visual analytics, data science, and streaming analytics. And these capabilities have been awarded a leadership position by Forrester, which is an analyst company that looks at all of the capabilities of software companies. And for data science, we've also received 3 years in a row a leadership position in the Gartner Magic Quadrant for data science and machine learning platforms. So that's probably enough about TIBCO. Let's take a look at what's happening in the markets. What we're really seeing is what we refer to as the great convergence. Organizations, companies, teams are looking at solving and producing analytics and AI applications no longer in silos with different teams, but really as a collaborative team. So we're seeing the use of different technologies, so converging technologies and converging personas. And the theme of our session today of visual data science is really it really caters to that need, because it allows you to collaborate with different people with different skill sets in one application much more easily. So we'll show that to you today. But first, we wanted to share a couple of real-world retail examples of how to use data and analytics. And we've got a lot of different examples. There's a link at the bottom of the slide that you can look at for more examples. But Ulta Beauty is a really good one and appropriate for this topic today. Ulta Beauty is the largest US beauty retailer. Think about skincare, cosmetics, hair products, salon services. They've got 32 million reward members, which are loyalty card holders, 1,100 retail locations, and a lot of online presence and sales as well. When we first started working with them, they really struggled to become as personalized as they wanted to be with their customers. They had inadequate access to all of their data sources. Everything was in silos. They didn't really have a good overview of all their departments and all of their customer interactions. They couldn't do the personalization that they wanted to do. They had some great ideas about letting customers test their products before buying, but all of that wasn't possible. And overall, they were growing, but they weren't able to keep up with sort of the streamlining of the business that they wanted to. So they started to really, revamp the way that they were managing the data. So they created a very customer-focused digital infrastructure for that data. And on top of that, they built what they refer to as use cases to be able to better interact with their customers. So first of all, they were able to do personalized interactions with customers. The example that I mentioned earlier about being able to offer specific experiences and different products. And this was possible across all of, or is possible across all of the different touch points. And touch points in retail are the moments where a customer interacts with a retailer. So that can be online, or when you pick up your product in the store, or when you're browsing the website for information. So these touch points are basically opportunities to interact with the customer. And they also created a more intelligent warehouse and inventory system, being able to, that allowed them to improve their on-time and correct deliveries. They also created a model where they look at historic purchasing data to predict and make recommendations on where to open new stores. So make better decisions on those. And they used loyalty cards data and supply chain data to look at the geolocation of where things are happening and look at seasonality. And we're much better able to respond to seasonal peaks like Black Friday or other holiday moments. So all of these things have really tangible business results, 14% year-on-year growth in loyalty membership, 10% increase in year-on-year sales, despite having a more complex product portfolio to deal with, and improved operational efficiency. So these, lower out of stocks because they're just able to manage their inventory and supply chain better. And this story is important, I think, to illustrate that if you don't have good data, it's really difficult to do good data science and analytics. But it's also important to think about these business impacts that you achieve with your data science, because invariably with marketing and sales, it has something to do with improving loyalty or customer satisfaction or NPS scores or increasing sales or cross sales or operational efficiency overall. So another example is Nature's Pride. Nature's Pride is the biggest distributor of exotic fruits and vegetables in Western Europe. They supply to retailers, wholesalers, exporters, and they have a lot of different varieties of products, including the ready-to-eat products like avocados, which means that planning your supply chain is really important. And Colin actually worked with Nature's Pride, is working still with Nature's Pride to implement a recommender, not a recommender system, implement a demand forecasting system. And I wanted to ask you, Colin, if you can just make a few comments about why that work is important for the visual data science theme of our session today.
Yeah, absolutely. So Nature's Pride, they've got all these different products, and they really needed to be able to anticipate demand, so they're wholesale and retail. And because they've got a perishable product, it's food, it's got to be transported, it's got to be flown across the world. So they really need to plan and optimize when these processes happen and when they can get it to the retail sellers when it's ripe and ready. So, but yeah, it's quite a challenging thing, forecasting. So we ended up working with building a univariate and a multivariate forecasting tool. It was very visually driven because it was non-data scientists. It was actually the business users who were using it. So they could build their own forecasts, analyze them and check them. And we actually spent a lot of time doing that visual analysis before we automated and put it into production. So it was key to get the business buy-in and to let them understand it visually without necessarily needing a data scientist to delve into that code.
Thanks, Colin. We've added a link to this page as well to look at the solution that you built, presented with the customer news, so that might be as well. So there are a few more topics or things that you can analyze in retail, and we've shared a few here, just for informational purposes for you as well, if you want to dive in a bit deeper. We recently did a webinar with Jumbo, big grocery retailer in the Netherlands and Belgium. So you can learn more about multi-domain data management for retail. We've got a solution that looks at promotional impact and goes all the way through to supply chain adjustments. So you can optimize your supply chain for, in this case, coffee shops. We've got a detailed solution for demand forecasting, really focusing on the different data science aspects of it. And also looking at a solution where you put a next best action in production. So looking at when you're using it, evaluating it in real time, what you can do to optimize it. So looking at all of these different opportunities for analytics in retail, Colin and a few colleagues and I decided that actually that customer aspect is most important. And we also really wanted to focus today on something that is very data science specific and shows the value of when you're using data science. So we decided to focus on recommenders, or next best actions, or next best offers. And next best action anticipates on the most personal and profitable interaction between a customer and a retailer. So it brings often surprising recommendations for a short-term offer, or maybe an intervention with a customer if they tend to be leaving your brand. It's the knowledge of a recommender is based on historic purchase data, but is really informed by the current context of the purchase. So, for example, if you're buying running shoes, maybe the historic purchase data has taught you that you should offer a customer, if a customer is buying running shoes, offer the customer some running socks, because that's are likely items to buy together. But if it's really hot weather and you are using weather data in your evaluation of the current purchase situation, you might actually offer a visor to keep the head of the runner cool, which is a much more profitable item to sell. So those kind of, I mean, that's a simple example, but there are lots of aspects that influence next best actions. And it's interesting because shoppers are actually really open to receiving recommendations. They generally view getting an offer as something that improves their shopping experience. So they're not really against it. They don't find it too creepy if you do it appropriately. And customers are very tech savvy, and increasingly so, but still 85% of retailers say that they don't have the right skills and tools and capabilities to do this appropriately or properly. So we feel that it's a big opportunity to learn more about and to advance our skills in this area. So we were looking at some research and some articles and blogs on recommenders, and also came across this presentation from Tom Davenport. This was part of the Datacated conference that we were presenting in as well. And Tom Davenport, I'm looking at my notes here just so I say it correctly, but he's President's Distinguished Professor of Information Technology and Management at Babson College in the US. He's also listed as one of the top 50 business school professionals by Fortune magazine. He's a very well-known author and presenter, and I've put the recording in this slide because he gave a nice 15-minute overview of what next best offer or recommender is, consistently what I just explained to you, but sort of detailing all the different aspects of a recommender, and also confirming that it's quite a complex methodology and that it can go in a lot of different directions, but it's really high value. So you'll have this for reference available as well. Now, Colin and I wrote it down in a bit of a schematic to understand sort of all the different options that you have when you build a recommender. So you'll have this available to you as well. And basically it's no different than any other data science project. You follow all the normal steps that you would do when you build a data science application, but obviously you're working with customer data, which David already said it's tricky, and you also need to have a specific marketing or sales goal in mind. So with that, I'll hand over to Colin to show how you can build a recommender actually in the tool itself.
Great, thank you. I'll share my screen. So, excuse the dog briefly. So she stars in many of my talks, as you may expect. So what I want to do today is really talk about this visual data science process that I've used a lot and we use here, and try and talk about why that helps, and show you an example of this sort of idea of a retail recommender. You know, visual data science, what it really means is we're starting to visually interact with the data science. It makes it more collaborative and it makes it more interactive, and you're able to iterate and evolve a lot better. You know, even things like finding mistakes becomes easier. So I want to show you how we combine that with tools such as Python, but leverage an interactive analytics tool like we've got here that we're going to use and do that. So one of the key aspects is obviously the data and what you want to do with it and the data limitations that your data set may bring. But another key point is when you're doing things visually, you can pass it out to the business more. And why that's really important is data science really is a collaborative process. You know, if you, I'd be curious to find out what people who are listening think as well. But my experience over years, over multiple companies and industries, that the only way you get to succeed using analytics and data science is when you work as a team with, you know, non-data scientists, you know, with business experts, domain experts, and being able to communicate effectively with them and make it a very iterative and collaborative process is key. And so being able to show visually your data science to people is really powerful. And it means your data science work has a bigger impact, but also means that business will buy into it more, and hopefully you get bigger benefits. So key to that is keeping a focus on the really pain points your business, speaking to people, understanding your use case. So our use case is, and I'm going to sort of build up and tell you about what went wrong. I'm going to show you what went well and the limitations of what I'm doing here. But it's just an idea, and I hope you feel that this visual way of working is something interesting and worth learning about. So let's start with the data set. We've got this transactional data. So obviously the starting point is gathering all your data, and you know, anybody who's worked in data knows it's quite often messy, disparate, you know, and you need to bring it together. So for my example data, I've got this purchase history, and I've just shown it here as a table, and it's your classic time series transaction data. Each line is a transaction from one customer. We've got a customer ID, we've got a product category. So you can see this is using data from a retail example. It's got a product individual code, the quantity, revenue, where it was bought, and the time, of course. So not a lot of information to work with, but we're going to try and see how far we can go with just a limited time series of transactional history. But one of the key points I'll mention is that missing or lack of information may change what you do throughout this process. You may not have the perfect data, and adjusting to that is really important, and learning about that is really important, because you could then use that to recommend how the business changes collecting data. We've got some information here about product categories, so that will help us look at these products in a bit more detail. What department are they in, sub-departments. We've got a little bit about our customers, not a lot. So we've got their registration date and a rough postcode, so not a lot of detail. I stress that this is fake, so there's no real people information here, and then some geographical data. So the first step in that slide that Heleen was just showing is we want to join the data together. So even at this stage, I like to do things visually. So we use this tool, it's a typical Spotfire tool here. It just shows how we can join different data sets together. So what I'm looking at is this purchase history, the product overview, and customer details visually represented as a flow. And what we've got is the purchase history here, you can see it. We've got the product overview, and then we're actually joining it together. And in here, I can configure how we join the data. So I'm joining it on categories. I can choose what columns come in, and I can choose what type of join it is. You know, if your database style joins can do lots of different joins. And I can visualize here the result of that join before I do it. And that's quite nice, because doing joins like this in Python also is quite easy, or R, or whatever language you use, but it's harder to see if it's working right, and it's harder to check, whereas I can just see this. But I think one of the main reasons I wanted to show this is when you have a flow like this and you can understand how each data table was joined, then if somebody new comes onto the project, or if you move on to a different one, or a non-Python coder comes in, for instance, they can understand this flow a lot easier. So it makes your data and process more maintainable and sustainable. So I used that to join the data and pull it all together and produce this one big table with our transaction data, our category data here, and then our customer data. So before we get into the data science, it's always a good step. And I think the data science is really exciting. And sometimes certainly I am overly keen to jump to the modeling without doing the really important basic steps of just understanding your data. You'll learn things about your data, and that might be really key to finding issues or opportunities with what your data science models say. So I've built this simple dashboard here that I can learn about my data a little bit. I can see geographically what's been spent. So the more pink or purple, the more spend. I could highlight, for instance, London and the south, and all these other charts change to actually react to that. So I can get some regional feel. Here we've got different product departments, how much was average monthly revenue. So we can get a feel also for instance, seasonality. You can see here January is a big month, and December, as you would expect, and November with sales and Christmas, etc. But this is just a nice way to get a look at your data set, and we can even filter it. What if we just looked at clothing, or what if we looked at sports and outdoor, for instance? You get a different trend, or maybe different things. And we've got things like this waterfall chart here that shows us, for example, how the total here in blue that was spent each year, and then what contributed to it. And I can, for instance, slide this along and see how much clothing contributed, etc. So the two things I've learned from this page that I want to take forward into my data science was 2019, for some reason, was a much bigger year. If you look at it versus the last 2 years, it's more than double 2018. So something's gone on, and that's not in our data. So we should be aware of that. Maybe there was lots of promotions, maybe the marketing was successful, but we don't have that information. So we should be aware that this year's quite an increase. The other thing that I think is interesting to take forward into data science is looking at the pattern of purchase. So the days between each purchase. And here I can see this histogram of how many customers and the days across the x-axis between purchases. And you see this sort of cyclical loop, and it's exactly on 1 year. So there are a lot of, as the monthly data shows, there is this sort of yearly trend when people come back and spend a lot. So we've done some analysis, but let's actually do some data science and see how we could use that for making various recommendations and try and tackle our use cases, which are, we want to do personalized, nice, suitable recommendations for different groups of people in who shop with us. So this is the first example of where we're going to show how we interact with data science inside a visual tool like this. So what we're going to do here is we're going to take that data that we saw at the start, so all our purchase data here, joined with this, and we're going to pass it into a market basket analysis, and we're going to calculate that market basket analysis, or it's often called affinity association, using Python. But what we're going to do here is, for instance, we're going to filter the data and say, well, what if we wanted to do market basket analysis just for clothing, or just for sports and outdoors, and only for a certain amount of time? I can use these filters and selections and then hit run affinity analysis. So you're probably wondering, what on earth is it doing? Well, actually, using this tool, what it's actually doing is it's calling out to what we call a data function. And these data functions are code, so Python code. So here you can see the Python code that I've written. So it's very similar to Jupyter, or if you're working in Visual Studio Code. So what happened is when I click that button, from the Spotfire tool, it actually filters the data, passes it into Python. Python reads it in, so this input df is actually coming from my tool. It runs all this code, so I do things like encoding the data. I use this Python library from the ML extend package to do the market basket analysis. I do some data manipulation and fixing and sorting, and then at the end, Python then returns the data back into this tool. So by doing this, a data scientist could write the code, but I, as a user, don't need to be a data scientist. Anyone in the business could now run this. So I've now built an affinity table and affinity analysis. So you can see here my scores. So your antecedents are what was bought, and then what is your most likely cross-sell. And what you get out of the affinity table is these three key scores. Support is how popular an item is. Confidence is how likely this, so for instance, jeans are bought alongside polos and clothes. And lift is a combination of confidence and support. So it's confidence, but accounting for how popular each item is. So we're going to focus on lift. And what we can do is use charting here. So often if you look at Python blogs about doing this, you'll see these types of charts where they plot lift and support and confidence. For instance, we can highlight the top lift items here. But you notice it's very interactive. When I highlight them here, it highlights them on this chart, and it also highlights them in this nice network chart. So we can use all this information to actually even get a feel for recommendations now. So if I change this and build affinity analysis for all data, so I've gone back to all data rather than clothing, I can just click a button and I don't need to worry about the Python code. It's just executing. I know the data scientist who wrote it has chosen the appropriate techniques. I just get to benefit from actually and focus my time on actually interpreting these results and seeing if we can make recommendations.
And Colin, if I was coding in R, could I do a similar approach?
Yeah, absolutely. You could code in R or various other languages like MATLAB. So the key thing here is that you can call out to those tools, and and you build a process up where you call Python or R at the time you need, and then do the work in a visual tool like this between those stages. So here we can see, for instance, the top lift score here is this cold weather accessories and with sunglasses or outerwear and shoes. And what we can do is start to use like complex analytics and visuals. So, you know, an affinity table, people use these types of scatter plots, but it's quite hard to see all the patterns because they're just 2D. But again, the point of visual data science is we can use more complex visuals here. So if I just give this visual a little bit more space, what this network chart is doing is it's showing us lots of things at once. The size of the node or the bubble, if you like, is the popularity of that. So we see sweaters are clearly our most popular item in our shop, but we've got suits, outerwear. The lines connecting show that what the affinity or the market basket analysis says you could cross-sell. The color of the line is the strength of the lift. So the more pink it is rather than blue, the stronger the lift score, i.e. the better cross-sell opportunity. And the thickness of the line is just the confidence, so a slightly different thing. So we can start filtering this and saying, well, let's look at our results from our data science, from our statistics, and let's look at just the top lift scores. And now you see my network chart changes, and I can see, for instance, toys and gifts have got very strong lift relationships with these items here. You can see sunglasses, etc., and tops, and you can see some other things like running clothes linked to shorts and trousers and sports, etc. So we've already got an idea of what items have got strong chances to cross-sell. So we could start recommending straight away from this. The marketing team could use this to do basic recommendations straight away. We can even look at, you know, let's just pick on things with high support, so items that are popular. And here you can see that sweaters is very popular, but actually all the items associated with it, there's not a lot of confidence or strong lift. So that for whatever reason, when people are buying sweaters, they don't tend to buy other stuff. So we're learning lots that we can take into a marketing campaign. So this is great, but one of the things I like to do in data science is combine different techniques. You know, I think in data science, you know, the one size fits all, if you excuse the pun, given its clothing, for me, doesn't always give you the best data science model. What we want to do is combine different techniques and try them. So this affinity analysis is good, but it just looks at transactions and patterns in transactions. It doesn't look at purchasing styles or behavior in individual customers. You know, it doesn't look at the time between purchases, etc. So what we want to capture how individuals behave or groups of people behave so that we can make it really tuned to that person. Because at the moment, this is just a very generalized for all our customers. So what we can do is use some clustering techniques. So I'm going to show you a couple of ways to do clustering and optimize it, and then we're going to pull it all together and try and see how well our recommender works.
And Colin, at this stage, would you already be talking to the subject matter expert, your sales or marketing contact as well, to share the first results? Yeah,
absolutely. I mean, to be honest, I would never start a data science process without doing that. And I would make sure it's very much a team thing, that we're constantly talking about it. You know, I could do this this page and send it to them for them to try, but we could sit down and debate, and I could learn from them, and they could say, oh wait, sweaters, that doesn't really make sense because of this, or actually this offer was going on then, so that's probably why you're seeing this outlier here. So that domain expert knowledge and understanding the marketing involved is really, really crucial.
You might make changes to the data as well as a result of it.
Yeah.
Data sets, or,
yeah, for instance, I found this data was lots of infrequent purchases, but I found there was some customers who had massive purchases compared to others, and it looks like they were possibly wholesale. So we chose to remove those because we're trying to do recommendations to actual buyers. So our data set was a bit of a mixture, and we had to clean it up. So one of the key things you do with clustering is obviously picking your clusters. It's one of the challenges of clustering. Often people will do things like use elbow plots, which is great to sort of optimize how many clusters might be good. But what I'm going to use here is a done index, and that's a technique that I find very useful. And again, you can do it through Python, and I'm going to run it interactively here. Before I show you it running, just to explain again, one of the challenges that you do in data science is, you know, the data set we're using is, as I showed, time series data. So every row is one individual transaction, but that's not going to work for clustering. Clustering, you need to represent each item or each customer in one row. So we've had to do some, if you like, feature generation, where we transform our data and generate features. And again, I've done that using a visual tool here. I've built this new table called Product Purchase Summary. And what it's done is it's taken our time series data, but I've applied a transformation, which is a pivot. So for instance, I've taken each customer, every product group, and counted how many transactions, summed the quantity, averaged the revenue that they generated. And I've also done that twice on different departments and different things, because you may not know the best features to generate. You may not know how detailed to go. So one of the, for instance, in this campaign, I'm using product categories rather than individual products. And that might make a lot of sense for clothing, where products constantly are renewed and changing. But if you were in a grocery store, it might not make sense to focus on groups. You could, for instance, the same products might be available for many years. But here's my features. I've got quantity of different groups, you know, dress shirts, cold weather clothes. I've got revenue generated on average. I've got all these different categories. So we've transformed the data. We've now got one row per customer, and that will allow us to try and cluster customer purchase behavior and see what products are associated with what groups of people. But to do that, as I mentioned, we don't know how many clusters there are in our data. That's one of the challenges. So what we can do is use this done index, and I can say, again, interactively, let's say set a minimum clusters of 3. I don't want to handle more than 10 because that feels quite a lot of clusters to deal with and visualize. I'm going to choose my initialization method. So this is going to be a k-means clustering algorithm. I want to up these factors and do a bit of a deeper analysis, for instance, and then I can click calculate done index. And again, it's exactly the same as a market basket analysis. It's passing this new table into Python, and then it's running this code here, this done index code that you can see, and it just uses typical package like sklearn to do k-means. And it's doing, you know, some things like filling in blanks where there's no data, we want to put zeros in. Scaling the data, it's important to normalize your data when you're doing clustering, or it will get skewed potentially by high values. And then we're looping over all our options, running k-means, and using a bit that doing the done calculation at the end. And again, once that's ready, it will return the results to Spotfire. So this really gives us a head start, you know, because it is hard to know, especially in such a big data set, what the ideal clusters are. And with the done index, what it's trying to do is it tries to maximize the distance between clusters, so the biggest differentiation. And it also tries to maximize and account for how close the items or people, customers in each cluster, make sure they're close to the cluster center. So it tries to optimize both. And once it's ready, you get these sort of recommendations of what the top clusters are. So it's finished, and here you can see it's recommending 5 clusters, gives me the best split. So let's take that forward. So this is very much a process, you know, you learn, you gather, and you move on. So I've got my done index chart here with my highest score of 5, which looks good. So I can now use the exact same technique, interactively change the clustering. So I'm going to say I want 5 k-means clusters now. I'll leave this, quite happy with these settings. So again, as a business user, a marketer, or you know, a data scientist, I can easily interact with this tool. And this is where visual data analytics and science comes really into play, because clusters are hard to view. There's lots of ways to view it. So I've built a few charts here and a few tables, and it'll allow me to explore those clusters. So it's just finished. My Python code is finished. And what I've got here is a legend. So I've got my 4 or 5 clusters. So the blue is cluster 1. This pink is cluster 4. I get a summary of the clusters here, so I can already learn about those clusters. So I can see most customers are in this cluster, and they're buying a lot of clothing. I see that it's mostly men's and women, not so much around the children's clothing. So the size of the dot in these charts is telling me how many customers are in that cluster for that category. And the x-axis here is the average revenue spent by that cluster in that grouping. And we can drill down to get more detail. So I can go and say, well, what clothing is most important? So you see there's a lot of high value cluster here with suits. A lot of sweaters are being bought. So again, if we click on cluster 4, we can see massive amount of sweaters, high value suits. And we can see how this cluster compares to the average revenue overall. So you can see if it's below or above average revenue. We can look at other clusters. For instance, cluster 1's got a lot of points below average. Cluster 3, even more so, and cluster 2, 5. But one of the nice things here is we've also got these pie charts to help us see if there's lots of differentiation. So for instance, you can clearly see that cluster 4 here is heavily clothing. So mostly they buy clothing. So if you've got a customer in cluster 4, they're very heavy towards purchasing clothes. But this cluster 1, for instance, you can see in the purple that it's almost 50-50 with a few others on outerwear and clothing. So it's a different buying pattern. So we've already learned a lot, and we can see even, you know, this cluster is mainly women's and men's, but this cluster again is very balanced with a mixture of children's clothes. So we've learned a lot about clusters. I'm quite happy with this. We could now use this with our market basket analysis to produce recommendations. So what we could do potentially is rank the market basket analysis scores and alter them based upon the cluster, so it's much more personalized. So if customer A is in cluster 5, possibly you would change the market basket analysis to adjust for what cluster they're in. So now we've got our clusters. The other nice thing about doing this is I'm just clustering on products. You might want to look at behaviors of timelines. You could build one big clustering thing that takes into account buying patterns as well as products. But in this case, I think it's better to kind of build focus clusterings. So I again used the exact same technique, and instead this time I built features on the frequency of purchases. So forgetting about products, let's just look at how many days between purchases, how much money do they spend in, you know, revenue in the last 60 days, 180 days, how many transactions. And again, using the done index, it recommended 9 clusters. So I set my k-means and did that. And I get some really nice, interesting patterns here in purchases. So this box plot shows how much revenue on average was spent by the customers in these clusters in the last 60 days. And what is the average days between purchases in those clusters? So you can see this cluster 2, they don't spend a lot of money. They're near the bottom, and there's a massive amount of days until they purchase. So this is like a low value, really low recency. So, you know, time between, they only buy every couple of years. But then you've got these 2 clusters here that look really interesting. Lots of high revenue, they spend a lot of money, and they do it frequently, or their average purchase time between in terms of days is frequent. So again, this is really powerful because I've got groupings of patterns that we can target for different campaigns. And because this is based in transactions, a customer may jump between clusters. You know, 1 year they might be not buying a lot, and then they might move into this. So an idea for marketing might be, can we move these low recency customers into a more frequent recency or higher purchase? And that might change how your marketing is done. You target certain groups. I got a little bit carried away, and then I thought, well, we've done all this. Could we actually predict to the day or near the day when an individual customer buy again? And this is part of the data science. Sometimes you go too far and you fail. I think it's nice to show that and learn from it. And that's something like we work with the Mercedes F1 team. It's something they talk about is you got to learn quickly, and failure is not necessarily a bad thing. I tried to build a regression to predict individual days of when they would next purchase, and it got a really poor R-squared. And that might tell me things like we're lacking information, maybe my features are wrong, but I could learn from that and say, well, I think we need to gather more data to do better modeling on this type of thing. But I'd quickly disregard that and say, it's not working. So let's just focus on how well we can do with the clustering and the market basket analysis. So the last thing is pulling it all together. So this is where the marketers in your business can really benefit from this together. And again, it's going to be very visual, but when you deploy this in real time, you get some interesting things. So what I've got is I've tagged those clusters you saw here. So I've labeled them, are they frequent buyers, are they higher spenders? So now we can see, right, we've got 947 customers who are medium recency, so they buy in between average times between purchase and low spend. We've got a really interesting one. There's these 39 customers they buy often and they spend a lot of money. There's this group who don't buy often and don't spend a lot of money. So we could pick out different marketing campaigns for each. Maybe we want to focus on these customers and convert them into medium recency, low spend, or a medium spend or a different cluster. Or we might want to target these high recency people who've spent a lot of money, but maybe because they've just spent a lot of money, they're not willing to spend again. But let's try and do some custom recommendations to finish. So if we take, for instance, our main cluster group here, and we click on a customer. So what we're seeing here is this customer did a purchase of jeans, and they're in product cluster 4. So if I click on that, what this screen does, is it shows the recommendations here on the right. And this is based upon the market analysis. So the biggest score. So it's saying if you buy jeans, recommend shorts and trousers. Second best cross-sell is shorts and sweaters. And third is polos. But there's different things. It's not always cross-sell. You could just suggest like most popular product. You might like this, sweaters are the most popular product. Or something different, the least popular or the furthest away product from their style, but still is in their cluster of product purchase behaviors. And what we can see down here is this cluster 4, you can see from the pink dots, they do spend a lot on sweaters and they do spend a lot on suits, and it's mainly adult, particularly women's clothing. But this is just using the market basket analysis. So what I want to do is weight it based upon my product clusters. So I did a very simple thing by taking my product clusters and looking at the average spend and the number of customers. I created a score to weight these recommendations. So let's try and see what the difference is. So when I click yes, it changes the scores here. It's applying a weighting based upon their individual person's product cluster they belong to. So now you can see it's recommending shorts and sweaters, shorts and trousers, and sweaters. And the most popular products are sweaters and suits. And something different to try is a cold weather accessory. So if I just turn off the weighting, you can see it's sweaters and outerwear. And actually that's interesting because outerwear, isn't particularly, it's reasonably popular, but it's not as popular as suits and sweaters for that cluster. So we can try it for a different customer. We could look at, somebody else in a different cluster and see what they've done. So let's look at cluster 1. So again, it's highlighted in the pink, and these are a low spend product customer. They're below average, you can see from the pink dots. And they actually spend mostly on children's clothes, so a different style of customer. And they've bought clothes and outerwear. So again, without the recommender on, it says toys and gifts and shoes are the best thing to recommend for cross-sell. We turn it on. Actually, the weighting just agrees. So that's interesting that our weighting hasn't changed the recommendations, but the popular items that you might also recommend does change slightly. So you can use this as a marketer. You can say, let's target these people and let's pick the top 50 customers based upon how close they are to a cluster and do that. So I'll show one last, hopefully interesting example of how this recommender really works, even though it's very simple. I take my high recency, very high spend. This customer here bought running shoes and shorts. With the weighting off, it recommends sports accessories, trousers and shoes. That makes a lot of sense, running clothes, sports accessories. But actually, when we turn the recommender on, it flips it and it says trousers and sweaters and shoes are better. And you think, well, they've bought running clothes and shorts. Surely the first recommendation was more sensible. But if you drill into it, they're part of this cluster. And if you can see, the first recommendation was sports accessories, and actually in cluster 4, sports accessories is one of the lowest things that's purchased. Very few money is spent and very few customers. So it's maybe not a good high rate of success if you recommend that. But if you look at trousers and sweaters, for instance, so if we look for the pink dot there, it's got a lot of customers with trousers and sweaters. It's got the biggest cluster, most customers, a lot of spend. So actually, even though it might not seem intuitive to not recommend sports accessories, the cluster they're in shows that they're not likely to buy them if our clusters are right. They're more likely to buy these products and cross-sell. And of course, one important thing is to test the theory. This is just theoretical. You got to try it, record the information and see how the customers react. And again, learn and feedback.
And that's something that you could do, we learned that actually from the N. Brown session, the other sandbox session a few weeks ago. You can do that with A/B testing to just see if it's a high risk choice, or you can put it in production and look at the results and make some adjustments accordingly. Yeah,
absolutely. Doing that testing, A/B testing to see the likely uplift, the benefit. We have a demo which is somewhat similar. I'll just show this to end before we can open up for questions. But this is a real-time dashboard demo of the fictional telecommunication company, and they're putting out offers on phones. So this is the type of thing you could do. You could deploy your recommender engine into real time. It could be monitoring clicks on your website. It could be monitoring people buying on the app or in your store. And what we're doing here is it's telling us, we've got this real-time dashboard to check how many people are accepting offers. And what you could say is, well, let's set a limit on our recommender. If less than 35% of people accept the recommendations or the you might like, then we consider the model not performing. So let's trigger an action, a warning to a marketeer or the data scientist to rebuild or learn and change that model. So it's very important to monitor and adjust, and then learn and improve. It's very, like I said, an iterative process and a collaborative process.
Wonderful. Yeah, we've done this with an insurance company as well, right? For pricing recommendations. So it automatically triggers rebasing of the model if the acceptance rate is below a certain threshold or above a certain threshold if the market changes.
Yeah, absolutely.
Great. Thanks for this demo, Colin.
I'll stop sharing that.
Yeah, let me just show one slide before we go to questions, because we have a lot of reference documents as well. So if you download the slides from the TIBCO community, you'll get all of these links. And I saw that there was one question about what is the software that we're using. This was TIBCO Spotfire. And we would invite all of you to try that at home or in your organization. If you're a student, you can try it for free for a whole year. Otherwise, you can get a free trial for 30 days. And there are lots of educational materials. We also invite you to join our monthly Dr. Data Science sessions. So there's lots to learn. Our contact details are there as well. But let's maybe go into a few questions. Actually, I'll show you what the community page looks like that Amy will share the link for. So it's very simple. You can recognize the session. You just click on download the slides and you have the slides available to you. That was our session.
Amazing. Thank you both very much. Delivered as promised as well. Very interactive session with some great takeaways. So as you say, we will jump into the Q&A and fire through some bits from there. If anyone has been enjoying that as they're been watching along, please do stick a little message into the chat. It is nice to see some thanks coming through, and there's really one there come through from S-Job. Thanks, Heleen and Colin. I really enjoyed that and learned a lot. So thank you very much for that. And as a few more come through, we will jump to the questions. So I will start with that very top question from Hamad. I think obviously you two are in a very lucky, maybe it's a lucky situation where you get to experience lots of companies, a lot of variety. You're going to have seen this across a number of organizations. And Hamad's question there at the top is, I guess, around, what are the common problems that you see in retail organizations that stop them from getting the most out of their data? Is there any particular things that you quite often go into an organization and say, this is your starting point, we recommend doing A, B, or C to get things moving?
Yeah, maybe I can start with answering that question. I think, I mean, the first thing, it's a bit illustrative of the Ulta Beauty example. It's lack of access to data. So unfortunately, that's still often the case. So often data scientists spend a lot of time on data access and data cleaning before you actually get to the data science aspect. So that's a common problem. I don't know, Colin, if you have other experiences.
Yeah, I mean, for me, it is the data. You know, it's we talk about big data and how we have AI and ML, but a lot of companies have not got to grips with what data to gather yet. That's a big gap. You know, this example, I was really my aspirations were somewhat curtailed by the very limited data set. I wanted to do a neural net over time, so it just wasn't possible. And it's good to recognize that and feed that back to the business. Say, look, we can do these things, but you need to invest in collecting data. The other thing I think is just a cultural acceptance as well, like people being able to explain a model. You know, if it's black box or if they're not quite sure how it works, being able to visually explain the impact is really important to get buy-in from your business. And just the skill set as well. Not all companies have people with the relevant skills. So I think that's something that's improving every day as more people learn data science and analytics and get experience. But I think those are the three things that I've experienced from most companies I've worked with.
Yeah, some good takeaways there, definitely. And it's obviously a big part of the job. It's not always the most glamorous part of the job, is it? But it's absolutely key. So fantastic. In terms of the chat there, a few messages coming through, very interesting, great to see the collaboration. Thanks from Andrew. Fernando asking if it's been recorded. Yes, it's been recorded and that will be shared online as well. Paul Morrow, great and very topical presentation. Thanks. Dave Mason, very much enjoyed that talk. Thanks. Rob Lancashire, Hamad, again, both saying how much they enjoyed it. So yeah, it's nice to know that there's people out there at home when you're presenting to a webcam. In terms of what you were talking about there, in terms of getting the information across, one of the things I personally really loved in terms of that session was the visual piece of it. You know, you've clearly created a data product. It is easily usable by the business, by different stakeholders, and the visualization piece of that is, you know, was absolutely fantastic. Just wondered if you had any recommendations, you know, if someone is looking into getting into this way of working using the visual design, you know, what's the best way to go about learning that? And is there any, you know, recommendations or resources that you'd recommend there?
Yeah.
I'll start, or you go ahead.
Do you want to start, Colin?
No, you start.
Okay, so the resources that we shared definitely give you access to some of the sessions that we've done on visual design. There's a lot of things, tips and tricks that work for any tool that you use. You know, the thinking about the use of space and the things that you show, what you hide, what you actually want to emphasize in terms of color and how you work on the visualizations. So there's a lot. I mean, you just have to practice and just practice and see how your message comes across. Also, you'll know when you make an impact, and based on the questions that people ask after looking at your analysis, you know what you have to work on to make that more clear.
Yeah, absolutely. I mean, there is the whole visual techniques about how much data you show. I struggled with the clustering because I wanted to show a lot of graphs. Was it too much? The color choice. But another factor of it is being so focused on your use case. That's something, even before my time at TIBCO, when I worked for our companies, I focus very heavily on. Make sure everything you're doing and adding to your visual analytics and when it's calling out to data science is helping target the one or two key use cases. Stay very business focused. So often when you're a data scientist analyst, you want to show off something, you want to put in an extra option, but really, does the business person need it? So you have to be quite critical with yourself and put yourself in the people who are going to take action, the people who accept the risk of publishing your model. What would they need to see to make a decision, and communicate well with them? And that's why I talk about collaborating and talking to them lots. The best way to get buy-in is to get them involved early on and make sure you're all on the same journey throughout the process, so there's no discrepancy in what you're trying to do.
Yeah, I think we've talked about that a little bit over a few weeks in terms of, you know, data science is definitely a team sport, isn't it? You know, you do need to get the buy-in from different teams, technical and not. And I think, you know, when you're looking at use cases like this that you've built here, it's a marketer's dream, really, isn't it, to
Yeah.
have this level of detail that they can access. So fantastic. And we're going to keep going with the questions in the Q&A. I'm going to shoot down to the question from Irfan and the one underneath from Ebru. They're both very specific to Spotfire. The question there from Ebru is essentially, what databases we're using. Are there any graph databases in the background? And I'll lean that in with Irfan's question there as well, talking about data pipelines and preparing data and stuff like that. How does it work in terms of connecting Spotfire to different data sources?
Yeah, so in Spotfire, it can connect to like a massive variety of things, SQL databases, cloud sources, Amazon Redshift, things like that. It can also read flat files. So that data canvas, that flow of data I was showing at the start, that was reading different sources and joining them. So that's one of the nice things about using an analytical tool like that, is I could join a data set from a database and join it to a file and then connect it to a cloud and do a join there. So that was all built into Spotfire. It lets you pull data in and then build up that flow of data. And then I like it because you can audit it and it's easy to understand as well. So that's really key there to get that going. And it's just part of the product that allows you to do that. Perfect.
Fantastic. I think, go on, sorry, Colin.
I was just saying, I can remember part of the questions was about how it works with the Python as well. So, it's actually transferring, it holds. So one of the things actually I should add is the way I was working was in-memory data. So it holds the data in memory and then passes it into Python. But you can do things like working in database, and then you might use tools like Spark and database rather than Python. So you've got a whole variety of ways, and the right way to do it, it's different for every use case, even within the same company. So I would always be open to trying different ways and different attempts.
Perfect, fantastic. And in terms of, sorry, Heleen.
I was just going to add to that. We didn't show that today, but we also have workflow data science tools. So you can actually work in database as well. So you can call and compute your data in database if you have really big data.
Perfect.
Can,
definitely good
in all directions. Yeah.
Good to know. Good to know. I had one question myself, actually, in terms of the pricing with regards to Spotfire. Is there different pricing models if you're the technical data scientist building all the models for then an end user in marketing that just uses it to view the visualizations? How does it work?
That's true, actually. We're not in sales, you know that, right? So
I'm trying my best. I'm trying my best for you, Heleen. I'm trying to get a few sales.
Yeah, I know. So there is actually a difference in terms of the depth that you need to use the tool, and the price is slightly higher for if you want to use all the functionality. And if you only want to view it, it's less, and you can actually share your analysis if it's just results for viewers embedded in any tool. Colin used to work at SEPA, Scottish Environmental Protection Agency, and all those tools were made available for the public for free. So quite powerful that way.
Yeah, one of the things I've always been interested in, 23 years I've been doing modeling data science, is always pushing onto the web or pushing onto an app. So for your end users, like the marketer could work that tool from a web page, and it could be running data science and stuff in behind the scenes, but they're just using a web page. So it means it's really easy for them to access and use. But for your data scientists, they need the full-blown tool to build that, to write their code. And that's a more, normally a more costly tool. So you get those tiers of users and somewhere in between. But it's just the point that pushing it out into a web thing or an app makes it really easy for other people to use it who aren't technical. And it makes it a nicer process.
Perfect. 23 years, Colin. I do not believe you.
It's 22.
I love the way Heleen was like, I don't work in sales. She was like, I'm a techie. Perfect. I'm a little bit conscious of time, so we'll go for 2 quick fire questions. We do try to keep this to like people's lunch hours in the UK. So two quick fire questions. The question there from Ebru, talking about APIs, that probably follows on a little bit in terms of what you were talking about there, getting data out into other platforms. Is there APIs that you can call in and push stuff out via?
Yeah, I mean, deployment of models is a whole topic in itself. So with TIBCO products, you can often publish a a file, like a model file, like a PMML, but you can publish an API. Or if it's a Python model, you can publish the Python model. You can call, for instance, you can call Spotfire in an automated manner. That's actually how I work with that Nature's Pride example. They automated the forecasting. So it can be an API you call to run that forecast, and then it does something with the data. It might push it to a database, it might send an alert, whatever. But yeah, but equally, because there's Python and PMML files, you could also write an API and call into these tools. So normally that's one of the things is data science often doesn't make it to production because you haven't thought about how do you deploy this. So thinking about your APIs and how that would work is really important. And think about that early on, because it might change what data you can access through an API, and it might change what models you build.
Yeah, good tips, definitely. I think final question, just to wrap things up. I guess there'll be some of the people out there watching at home that are, using Jupyter notebooks and things like that. How easy is it to move from, working with Jupyter notebooks to Spotfire?
Yeah, I mean, I actually often write my Python and Visual Studio Code or Jupyter, and then I transfer it into Spotfire.
Yeah.
You can write it, so you basically copy and paste it in. The only thing you handle then is you need to just map what data in Spotfire matches what variables in Python. And sometimes there's slight differences in how they cast the different types, a string or a time or a date or something. But beyond that, it's really simple. It's almost entirely copy and paste. But the nice thing is you then have this mapping that allows you to do all that sort of interactivity that I was doing. So develop in your favorite environment, push it into Spotfire, sort your mappings up, and then you're good to go.
Perfect. Sounds good. Although I think I was looking today on Twitter, and like Git have released a new AI that writes half the code for you. So
that's great.
Maybe none of us will have to write code soon. I don't know. I don't know. Perfect. I'm going to draw things to a close there. I'd like to thank you both very, very much for giving up your time to come and share with us today, and also giving up your time, obviously, to prepare the presentations and all of that content there for us. So clearly would have taken a lot of time behind the scenes. So thank you very much. I'd also like to personally thank you, Heleen. I know you've worked really hard on the data community from the TIBCO side of things for a number of years. So I'm really pleased that we've made this happen. Thanking TIBCO for getting involved and letting you guys free to come and play with the community, as it were, today. So yeah, thank you very much. Thank you everyone at home for joining as well. And hopefully we get to do this again, perhaps later in the year or something like that, see what you guys have been up to. But yeah, thank you very much, and we'll see you all very soon.
Yeah, see you in the rest of the sessions this month.
Cheers for the questions.
Goodbye. Thank you very much.